on this. Finding the total hydrostatic force on this triangular plate under the water. And we know that pressure equals weight density times depth. Force equals pressure times area. To get total force, we're going to have to add up lots of little bits of force. So we're going to start with finding a typical amount of force. So how can we find a typical amount of force? It's going to be, yes, it's going to be pressure times area. And how can we, what kind of area, so that we can actually do pressure times area? I mentioned this earlier. What will it be? Horizontal strip, right? A horizontal strip. And why do we choose a horizontal strip?
Because for the entirety of the strip, the pressure would be equal.
That's right. So we got a constant. It's going to be constant pressure. If you do a vertical strip, well, your pressure varies across the vertical strip, and it's not helping at all, right? It's the same situation as just trying to find the pressure on the plate. But by just doing a horizontal strip, the pressure is equal. So what should our frame of reference be? So again, we've got choices. We could make the frame of reference the top of the plate going down. Okay, that might make our life easier when it comes to finding out what the width of the strip is. We could make the frame of reference the water height, and then our depth is just simply whatever variable we choose. So I don't know. Let's go ahead and do that second one. So we're going to make frame of reference down to the typical strip from the top of the water, and we'll call that, we call it X, or we could call this Y and have X be a horizontal coordinate. It doesn't, so you've got choices here. So let's just go ahead and do that. We'll call the depth Y. And then we've got what? The width of this strip, because it's going to be our pressure, whatever pressure is, times what? A will be width times, what will that be?
The only problem is you have to change the input, so. You got these? I don't. I have mine in a 24. That's okay. But this is like minus 24. We want to get this. Yeah. I'm gonna change it. Yeah, I'm gonna. I like starting with this. Yeah, are you gonna go to the very top of the? No. Your reference frame is going to the top. I mean, I'm starting from the bottom where the triangle is. Y is 12. Okay. And then when you're like value of 0, and 120 x minus y. The reference is 120 minus y times 24. Oh yeah. But you because this just to get pressure. What? Row depth. Depth minus. That's like making you. Because you're exposed. I don't know how to. Yeah, I got the range. That's taken care of.
And what is that? 2.0 something? 08?
Okay, I think I have a typical script. If you start 12, so if you start, you would use the linear rate of change and say that the slope of the value of x, like x here to x
What is the width at 12 meters? What is the width at 12 meters? Look at your picture.
So if you do this, if you do the slope of polar, and then if you put that word down here, then you can put is going to be y equals 0.
Then you have to subtract the current on D6.
Oh man, I don't know why.
Row, what's row?
Let's see. Walk me through this. So, my rate of change, once I get to 96 centimeters, which is this point, it's going to be 50 over 24.
I have X.
So, what I did was I set my values to 96 to
I have only
right, and then I use figures
depth
X
is
and then here's my width right here.
Okay,
So, right, and have my change.
so at 0, so at 12 meters down here, you would get 50. You would get 50.
But no, because it forgot that row was input 96, and then this makes sense. Sure. I know. Yeah. So that means that now it's split into 1 minus y. Which one? Yes, that'd be correct. So it'd be and I'm just confused on what equation the branch is like. Okay, right. The x value here is like from 0 to 50, right? So and then base my point then that this would then be like I don't know how I determine.
Do you know?
I know this is right.
This is a constant rate change.
Yes, but it's the constant rate of change on both sides. So I don't
know, but it's still a constant rate change, right?
Right.
Two straight lines. So you can basically just do y1 plus y2 just 24. So this is y2 minus y1.
Right.
Next to minus so now, so you're picking y, right? So now, when you put 50 in, or
No, the thing is that
you're doing y.
is that when you have to get an equation for y, right? Like because the slope is not enough, you have to apply this to the line. That would make sense, right? Okay, so
No, so we just flip this over. It's 50 over 24 because we know since this is our dependent.
okay, yeah.
This is our zero. This is our inventory. So this is our manipulative. So now when you input 24 for y, those okay, so now this right.
Okay, just a couple more minutes. So,
Any questions?
all there at once. This is going to be a positive amount. So we want to start. We want to integrate from the lower to the higher value to keep it all positive. If you happen to switch something, everything's right. Say you integrate from 12 to 16, check to see the same value. If it comes on right, then it's just stops. I don't know how. This is my gotta go. But this is because it's all forces that are equally dependent. So we're just finding one of that value point, adding it up. Yeah, yeah, there's different places like I don't want to spend so it's all there. Yeah, so if you didn't divide it up, and you just solid value.
What is your
So this hover around
so like after 5, 6 days, it's not gonna afford
yeah, the program is how you use my one. It's not actually
This is just getting so depends on the problem. But in this case, your other possibility would be like this. Okay, so just briefly, if we were to do the frame of reference from the top of the triangle, then what would happen is this linear equation would be easier because when your y star is 0, your width is 0. So you'd have the point 0, 0. That makes this linear equation easier. But then what is the depth? So then when you do the depth, this d is no longer just y. What would the depth be? You still need the depth of your strip from the water. So your depth, this right here, instead of just being y, would be your y star plus 11.6. Because your typical strips still have to be how far under the water you are. Okay? So having this y star frame of reference would make this line, this linear relationship easier because you'd have the point 0, 0. But then you'd have your depth would be y star plus 11.76. So overall, that would probably be an easier way to do it than the way we did it. Okay? So what's that? The bounds would be different as well. Then your bounds would be from what to what? 0 to 0.24. From 0 to 0.24 if you did y star. the first little strip's at y star equals 0. The last strip would be at y star equals 0.24. Okay, other questions on this example? Did you guys work all out? I heard good discussions. Did you get these things worked out? All right, so another one. No, not surprisingly. Here we go. Great problem here. So an oil tanker has a cylindrical shape with a diameter of 12, a length of 74, so the length of the cylinder, and it's filled 3/4 of the height with gasoline, which has a density of 44.9 pounds per foot cubed. We want to find the total force of the gas on the circular side of the tank, and then how much work would be required to remove all the gas from a valve at the top of the tanker.
Please.
So can you take in a minute? Can you sketch the situation first of all? Having not given you an illustration, can you make a good sketch of it? See if you can do that in a minute. Just like you'd see it in a truck, right? So this is a oil tanker, a cylinder lying on its side, right? Cylinder lying on its side. Keep working on your drawing. Keep working on your drawing. Compare it with the person next to you.
It's laying down. Okay, you can keep going. Then, if you think you got the illustration, you can keep going. So here, in terms of frame of reference, we could choose the frame of reference at the center of the circle. That would make our equation of the circle the easiest. We could choose the frame of reference to be at the top of the gasoline. That would make the depth the easiest. Or we could choose it at the top of the circle, and that probably wouldn't have any advantage because then our depth would be weird and our center wouldn't be there. So when you have circles, it's kind of nice to make your frame of reference in the middle. So maybe so we're all doing it the same. Let's make y down from the center like this, and x positive x to the right like that. So we're going to make our y equals 0 at this very center of the circle, and that will make our circular equation the easiest.
For B, if the valve at the top of the tanker, like, does that mean it's not touching, where the gas is? Because, it's only filled 3/4 of the way.
So it has to be a pipe or something.
Okay.
Okay, go. Work on A and B, whatever. So what are we going to have? We're going to have a typical, again, typical horizontal strip. Okay, we got 11 minutes to finish them both. Just set them up. Just set up the two integrals, okay? But
Still a positive. Yeah. Oh, yeah. So are you good? Yeah. Well, you're almost why is describing right. That's what I was. Okay. So I had the 2 times.
Did you get that? Did you figure that out?
Yeah. So you're doing. No, so you take that. Yeah.
You had that before I wrote it?
Oh wait, what did you write?
I wrote, I made a step on delta F. So check, I made a little, it's a bit of force for the typical strip, so check that out, see if you agree.
Oh, that makes sense. Yeah. Oh, 2x. You didn't solve 2x for y yet, though.
No, I'm not done. Not done. So that's the last thing to do. So what is x in terms of y? You get it, but can you do it? You got to be able to do it. That's right. X squared plus y squared equals 6 squared. So x is? Questions? Please. Because we put the center of the circle here. So the depth below the surface of a typical strip is not just y. Y would be the depth to the center. So there's 3 more feet of gasoline here that I have to add. So the y coordinate is from whatever we chose the center, from the frame of reference. But that's not the depth of the strip. The depth of the strip is, I'm showing here, from here to here. That's the depth of the strip, which is part of its y, but then you have 3 more feet from here to here. Do you see? It doesn't look like the light bulb's going on.
No, I see what you mean. Where would you put your
Oh, bounds. Okay, so now, more questions on the typical force? Yeah. Okay, yeah, so why don't I use the 74? So does pressure vary with distance this way? That's why. So in the ocean at 10 feet deep, the pressure is the same as in my swimming pool at 10 feet deep. It doesn't matter how much lateral substance you have. So if you're doing the force on a vertical plate, it doesn't matter how much you have in any direction. Pressure is not dependent on lateral substance, just vertically. Okay, so then the force, quickly here, total force. It's going to be the integral from what to what? So
From -3 to 6.
-3 to 6.
So you did it as positive going down, right? From the center.
Yep. Questions?
On the exam, will we be able to choose our reference frame?
Maybe, maybe not. So I might specify what you should use for your reference frame. So yeah. Because we need every typical strip. Here's y equals 0. So we have typical strips up here. That's y equals -3. All the way down to 6 is at the bottom. So based on our y equals 0 being in the center of the tanker. Yeah. Well,
So I think you
the
have
y
to
plus
set up
3 gets us the depth, gets us the pressure. But then the bounds are about we need to have all typical strips. So all typical strips are going to be starting at -3 all the way to 6. So it's two different things, right? There's the depth of the typical strip. We got to add 3, but then we got to add up all the typical strips. The top layer is at y equals -3. The bottom's at +6. Okay. So the exam is Friday. Okay, listen up. Exam is Friday. So you got my email about all the review materials. That's all up there. Great practice in the book. You have this homework is due tomorrow at 5 p.m. You got till tomorrow. The web work is due at 5 p.m. Recitation today is going to be more finishing this problem, doing other problems for review. Anyone can go to that. So anyone can go to today's recitation. Same class both days. So if you want to go to that, we'll finish. He'll do this. Finish the work to empty the tanker, and then you can do problems from the book or work on the web work.